Hey there, folks. So, last episode had a bit of a turn in the process of what we were doing. Started working on item decay, went through and set up some basic decay logic. So, we gave an overall item condition. We added a Boolean flag as to whether or not the item will decay. We've got decay rates for based on the temperature the item is stored at. So there's the ambient decay, the cold decay, and the frozen decay. And that's for things like if it's going to be refrigerated, frozen, or just left out in the open. Um, and then there's just the base decay rate that we added in. And that is, all of this is just going to be used if the item is set to have like I'm trying to think the best way, a spoilage, like if it goes bad over a period of time. What I want to cover this episode, and actually before I go into that, we also went through and added in our tick function for working out the rate of the item condition decay. I do want to, and actually I didn't add this in here, to add in handling for spoil for zero condition. Never added it in last episode, and I'm still trying to decide exactly how I want to incorporate this. There's a couple of different methodologies. There is going to be something like at zero condition, it changes to a different item. At zero condition, it changes to a garbage item. So, like, just to explain, I'm thinking, what have I played recently that has something similar? Vintage Story, for lack of a better term. You've got, lack of a better term, lack of a better description. In Vintage Story, you've got where your food decays, and then once it hits that gone bad point and it's spoiled, you get something called rot, which is an entirely different item that you can use for other things. So there's a couple of different ways you can do it. So you could have it so like all of your foodstuffs decay eventually and turn into rot. Or to get specific, you could have like milk turns into spoiled milk, turns into something else, and you could go about it that way. So I'm still not exactly sure how I want to implement that. My initial concept behind it is I want it to go from like milk to spoiled milk to whatever. And then from there, I want to figure out how I want to do that. So, but anyways, this episode, as I was saying, what I want to expand on this is to add in and leverage this condition system for item durability. We have two different ways you could do that. You could add that entirely separately, where instead of having just a item condition value, you have an item durability value as well. And that's why I named this item condition, not item decay or anything like that. And the whole purpose for that being is I want to leverage this as both the condition of, say, a melee weapon or the condition of armor, and then also the decay rate of something that spoils. So with that, what I want to do though is we need to add in a couple of functions. We added in decay rate or decay tick to our item. We need to add in, this is going to be a blueprint callable one, U function void take condition damage float amount. And this is going to be a const reference. Actually thinking about it, const reference. And just for some explanation, I haven't covered this in a couple of episodes, but again, I like to bring this up every now and again because there's people who aren't proficient in C++ who are trying to follow along. So what the const keyword is it is saying I'm going to accept this input value of amount and I cannot change it. So what that says is this function will take the amount and it does nothing with it. Float, obviously the data type, and then the reference is basically saying this is something that we know is stored in memory pass me that memory slot. Don't pass me another copy of that. Just tell me where to go look for it. And the whole purpose for that is memory efficiency. You want to try and limit as much memory allocation as you can possibly do within your code, simply because if you're just creating new variables, like right here, these actually should all be references. We'll say we have 1,000 items, and each one of these three, is that three? Yeah. Each one of these three are, as they are currently now, a new variable. Effectively, those 1,000 items create 3,000 variables, because each one of these takes 3. Whereas, actually, I believe these can all be const, aren't they? Because we're not actually... Right? Yeah, we're not doing anything with them, so they can all be const. So const reference, const reference, and again, const reference. Helps if I could spell. And again, like I said, the whole purpose of this is just for memory management. Like, yes, a Boolean value is, it's a little over a byte when you get all of the additional stuff that goes with it, but it adds up. And that's the thing. You're like, oh yeah, this function doesn't really, well, sorry, this one here, it's 2 bytes and 2 bytes with the Boolean, and then, well, variable with the float. But you should be good now. What are you complaining about? Oh no, I remember why I did this, because oh no, I set that as a pointer for some reason. That's why there was an issue. Wow, it's going to be one of those days today. But yeah, so with that, again, it's memory management. You may think, okay, one item, this isn't bad. It's a float, which, well, it's, like I said, it's a dynamic amount of memory allocation. You've got 2 Booleans, which are the smallest amount of memory allocation you can have, because it's either a 0 or a 1. But then you have to think on terms of the scale of how many of these are going to be out there. How many inventory components are going to be ticking at once. So you're going to have things like that you want to try and keep in mind as you're going forward with things. And that it is that memory management. Using blueprints, it is a lot easier back in the code compilation. It does a lot of that for you. It's still not perfect, because you have the difference between references and pointers and new variables within blueprints as well. So, and that's where in blueprint you get the pass by reference. But ultimately, a couple of things to just quickly cover before we go through and create this function. So, constant. If you do not want the function that the information is being passed into to make a change to the value, or as you can see up here, you don't want the value that is coming out to be changed, then you're good. You don't use a constant, because what that means is this value is going to maintain its state constantly. We're not going to change it. It's not going to go up, going to be down. We're not going to clear it. We're not going to go from true to false, however you want to look at it. Reference versus pointer versus new variable. So how to explain the difference there? So a pointer is just saying, okay, this value was in memory slot A. It might still be there. Go look there. If it's not there, or it's a different data type that's been shoved in that memory slot, because you have to remember memory allocation changes, things move around as needed, you're going to have a access exception, and you're going to get a crash. A pointer, which is what I had done, that's using the asterisks instead. That's just saying, okay, go look in memory slot A. It might be there. Using a reference, is saying this value is in memory slot A. I just checked. Here's the, go find it in memory slot A. And then a new value, which is having neither the asterisk or the ampersand, is saying, okay, I'm going to create a brand new memory allocation for this value, and I'm going to put it over in this function. Now, there is situations you're going to want to use all of those. There's going to be situations where you only need to use a specific type. Sadly, it's situational. There's no hard and fast. But my recommendation is, if the information is being created in a previous function, let's take a look here. Do I have anything open? No. And yes, I'm turning this into a bit of a lesson here. Player character, where are you? Okay, so in here, we've got line trace by channel. If you take a look and mouse over, you can see these are all being passed in, with the exception of the collision channel, passed in by reference. They all have that ampersand, so F hit result space ampersand. The placement of the ampersand and the asterisk is up for debate. It doesn't matter. The fact that there's an ampersand in there after the data type is all that matters. So what we're doing here is we have our hit result. We are passing that in. It was created here, so you can pass that by reference. What that means is inside this code, which is just a pass through to a different function, inside this code, it can modify out hit, and it is going to change this instance of that F hit result, because it is not a constant. Now, if you look at that end position, it is a constant F vector reference. What that's saying is, this is where it ends. You cannot change it. Do not make any modifications. So, same with the start. Constant F vector start. It's a reference. It's because, okay, we don't need to create a copy of this. We've created one. We're going to leave it at that. So, anyways, that minor, like 10-minute aside on this, I want to go through and take condition damage. So in here, function is going to be pretty basic. Item condition minus equal amount. So this is where, again, as I was saying, we don't need this to be modifiable. We don't need to create a new instance. We're passing in, let's say, 10 as the amount. We just need to know we need to take 10 off this. We don't have to worry about doing anything to that 10. We don't need to worry about like passing back a different value. Now, this is where I also want to add in a to-do for add-in handling for zero condition. And you do have a couple of other factors we could include here. And I'm actually looking at my notes, and I do have them in there. So up here, oh, and I forgot to mention it, between episodes I added in this region just so I could close out and minimize all this condition stuff, because it gets a little bulky. I want to add in float condition damage multiplier equals 10F. So what this is, it's not base rate. Damage multiplier. So what this is going to be for, so I'm trying to think a good example. Let's say you have a pistol. You could have like a homemade scrap pistol that can like fire 2 or 3 times. You could have, before it needs some servicing, you could have that same scrap pistol crafted at a higher skill level that can fire like 5 or 6 times, and then a higher skill level it fires 10 or 12 times. But instead of having to do all that calculation prior to calling this amount, you just pass it in here, and all we do is amount times in brackets. So this is obviously done. This is PEDMAS, BODMAS, however your school system taught you this. So it's item condition minus equals the amount times the condition damage multiplier. And what this would do is say the base value is 1. So passing the value 10, it gets 10. The condition damage multiplier is 0.5, which means it's a good quality. And you have to remember multipliers below 1 decrease the amount. So 0.5, that value of 10 comes in as the amount. We're going to have the condition drop by 5. 10 times 0.5, 5. And the inverse of that condition damage multiplier is, let's say, 2. The amount comes in as 10. Well, we're going to apply a damage multiplier of 20 to the condition. So that's sort of like a judge on the quality of the item. So if it's like a junk scrap pistol, it could have a damage multiplier, a condition damage multiplier of 10. You get one shot and it breaks, sort of thing. Or you could have like a master crafted scrap pistol that could fire 100 rounds, so you have a damage multiplier of 0.1. And that's the whole purpose of this. So with that, we are actually only a little way into this episode, even with my 10-minute diatribe at the start. So I'm going to go through and add in a function here for this brain's not working. 0 durability, 0 condition. Now, and just to explain, the reason why I'm going to add in a function, as I've mentioned multiple times, more so recently than anything else, I do want to include modding support. And when you add in a function, you give a developer, be it a C++ or a Blueprint developer, the ability to override your code and change it to their own. So making a public function, you can see here we have, okay, let's grab this item base. Let's go down to melee item base. In here, we can go down, add this function in, and add in override. Override. If I could spell. I have to move this back. And here I am talking about this. Take condition and off. Maybe I have to go back to weapon item base. Equipable item base. Okay, that might be the case here. Equipable item base. U item base. Okay, let's see if this is just... Oh, no, I know why. Right here. There we go. It's because I didn't have virtual in front. Seeing this reminded me. So if you add the virtual keyword, what that means is, well, it can mean a couple of different things, but it means you can, any child class or any class derived of this class in its chain has the ability to override this functionality. So now I've done that, we can go back to our melee item base and throw that in for comparison. So in here, we could create our own melee item class that has completely different logic for take condition damage. Which reminds me, I actually have a lot of functions I need to go through and make virtual. But anyways, so we're going to clear that out. Don't want to save changes to that. Close these out. So with that, we're also going to A virtual void process. No. Trying to think, what do I word this? Process condition 0. Condition 0. And you have to use words, spelling. And this is just going to be no parameters, no nothing. So now we've got that. We can just call this function here and here. And what this allows us to do, and the whole reason why I've done it this way is, like I said, if we have just a, actually I'm going to show you in a blueprint, because I'm pretty sure I can override that in a blueprint as well with the way I've done that. Might need to add a keyword. But anyways, to explain, the whole reason for this is, as I said, for modding support, if somebody down the line, they want to create an item that when it decays, it explodes. I don't know. I can't think of what that would be, but after it has decayed for however long, like its decay tick, it processes. This gets down to 0. Actually, I need to add some behavior in there, some conditional checking, but we'll do that in a moment. With that, like I said, it decays down to 0. Actually, no, I'm going to leave it as is. We're going to put that in here. No. I'll deal with that in a second. I'll keep my train of thought going. So yeah, as I was saying, its condition drops down to 0, and after it hits that 0 point, they want it to explode. Like this is some modder who's decided to create, say, a joke mod, like there's for 7 Days to Die or whatever it is, and that after it decays, it explodes. So if you haven't eaten your bomb apple by the time it's decayed, it'll blow up in your pocket. They would need to be able to override and add in custom functionality to process condition 0. So what they would do is they would either in blueprints, I'm hoping, that's what we're about to check, create an override function, or in C++, if they are wanting to write code, they could override that function. And they could say, okay, bomb apple derives from consumable item base, but we need to override the process condition 0. So, build failed. Take condition damage. What are you complaining about? Melee item base. Did I not? I thought I removed that. Oh, no, I didn't. Oh, no, I removed it but didn't save it. That's why. But yeah, so trying to think if there's anything I want to say on that one. But yeah, so that explains, sort of gives you guys a general gist about why adding these in as an overridable function, there we go, adds some benefit, because then somebody else can come in and make some changes there, or you yourself, if you've decided later on that it's a case of, oh, well, I've got like 99% of my items do this. I need to create like this unique class that for a bomb apple, that it will explode when its condition is hit 0. So with that though, instead of me just continuing to sit here and rattle on, I'm going to pause the video and I will be back as soon as we are in the editor, and we'll check to make sure that we can actually override these functions. Alright, so we're back. Well, I'm back in the editor here. I just had that open in courtesy of that. Just opened up the mouse helmet pickup that we had. So in here, okay, you can see we can call the take condition damage function. and then functions. Oh, it's not overridable. I have to remember how to do that now. Okay, with that, let's just search in Google, actually. Allow blueprint to override. How to override. Oh, okay, so this is what we want here. Virtual. I really can't declare virtual. At least that's what I tell my experience, but come on. Oh, that was it. Blueprint. Okay. So with that, obviously I'm going to need to go through and change up quite a few of my functions and figure out how I want to do that, because I want to expose as much as I can to blueprints. So, sorry, I was just sitting there in silence reading that. But yeah, so ultimately what I thought was the case was incorrect. So what that's going to mean here is close out of that. I'm actually just going to close out of this. I don't want to save anything. So what that means here is my initial intent for this. I'm going to have to figure out a different way to go about it. But so process condition 0. We're going to deal with that here. So it's going to be if item condition greater than 0.00 return, and then otherwise this is where we would execute broken logic. So with that though, folks, we're close to we're getting close to the 30-minute mark, and this is where I wanted to sort of like just finish off with the item condition. Sorry, again, my brain is not functioning properly here. I wanted to just have this set up as this. What I'm going to do between episodes, and we'll cover it in the next episode, is I'm going to go through and figure out how I want to modify these functions so that they're blueprint overridable. And then from there, we are going to obviously go through and I'm going to do that between episodes, and then next episode is probably actually going to be covering that and a couple of the other to-dos I found within the items. So, but as always, folks, thank you for watching. If you have any comments, questions, concerns, suggestions, please feel free to hop over in the Discord, or you can leave them in the comments below on YouTube. I'm not sure what's going on with YouTube. I'm not getting my comments there. I'm not getting notifications or anything for it. So I'm actually actively having to go and look at like videos to see if there's any comments. And well, I've got like 120 videos now. So it's getting a little hard, 120 plus, to keep up with all of them. But as always though, folks, thanks for watching, and I will see you in the next episode.